Welcome you all to this Multisim Simulator environment. Today we are going to see AC waveform circuit with half wave and full bridge rectifier along with filter capacitors. Stay tuned and follow the instructions to learn this simulation software faster. Let's begin. We are using here the Online Multsim Simulator from National Instruments. To start with, we will first take a source. So where do I get a source? So coming over here, you can find here the source. Clicking over the source, you'll be able to see that there are a number of types of source: AC voltage, AC current, clock voltage, clock current, DC voltage, DC current. There are a lot of voltages available. For us, for this particular topic, we need AC voltage. Let us click on the AC voltage now. AC voltage clicked, drag and drop. So here you can see that if you want to close, if you want to rotate, everything is available there. Let us keep it like that. Let us fix a voltage for this. Double click this AC source. Here you can see that on the right hand side the voltage and the frequencies comes into picture. Let us keep it 10 volt and 1 kilohertz. Let it be like that. Now let us pick a resistor. So you will get the resistor from this passive. Click on passive, click on resistor and drop it in the workspace. Now you can rotate this resistor because to align it with respect to the source, rotate the resistor. Yes, so that is done. Resistor value by default it is selected as 1 kilo ohm. Now let us connect the wire. To connect the wire, take your cursor towards the source. You can see a wire spool comes in picture. Click on the wire spool. You can see that the first wiring is done. Let us do the second wiring again. Take your cursor towards the resistor second terminal. You can see that the wire spool has connected the wire and the circuit is already completed with the source and the resistor. Now you need to connect one more component, that is the ground terminal. Here you can see that the ground terminal you will be able to find in the schematic connections. Click on the schematic connections and click on this ground terminal and place it near to the bottom. Yes, there you are. Now you have got to make a wiring for the ground terminal. Right, so your source, supply voltage and the load resistor is ready and the ground terminal is also connected. So now the circuit is ready. Now before running, let us connect the voltage probes at the input source and also at the output load. So where do I get the voltage probe? Voltage probe you will get it at this place, the analysis and annotation part. Here click on this. When you click on here, you will be able to find out different types of probes: voltage, current, voltage and current, and many other probes are available. So for now, let us stick on to this voltage probe. Click on this voltage probe and connect it near to the source. So you can see that it is getting highlighted. Click over there. That is the first voltage probe which we have connected to the supply source. Let us take one more voltage probe that we will be connecting it to the load resistor, so that we will be getting both input supply waveform and the output supply waveform. Now we are going to run this circuit. So when we run the circuit, it will be showing the waveform generated through the voltage probe. Let us run this circuit now. So for running the circuit, you have got to come over here and click this play button. Now I'm going to click that. Yes, there you are. So it has been clicked and you can see over here the voltage probe, both at the input level and the output level. The voltage is getting displayed, but it is continuously running. As you know that it's an AC source, so AC source, the voltage will be fluctuating from a negative voltage to positive and then coming back to negative, and it gets done continuously. Let us pause this at a particular point. You can see that that is negative. Now let us pause it to a positive value. Yes, there you are. So that is positive voltages at the input and output. So it's also very clear that input voltage is the same as output voltage. Input voltage is marked green and output voltage is marked blue. For getting the waveforms, you have got to click over here graph. So you'll be able to see the waveform, but presently the settings are not right. We will be arranging that settings. Now before that, let us go and click this split. When you click over the split, you will be able to see the schematic diagram and also the waveform at a stretch. Now let us change the settings of this waveform. For changing the settings of this waveform, click over the waveform and then you can see that on the right hand side there is the time frame and also the voltage. Let us change the time frame from 0 to 10 milliseconds. So let me change this over here to 10 milli. Now you can see that the waveform is pretty clear. The waveform is blue, but there are two waveforms over here, as you can see over here, PR1 and PR2. What are PR1 and PR2? Those are the two probes which we have already selected. The green probe is PR1 and the blue probe, as you can see over here, is a PR2. Let us see whether we can see both waveforms over here. For that, we have got to click on this wave once more, and you can see here, if you want to just see PR1, just remove a PR2 from the screen. You can see that it is green. So green is the source voltage waveform and the blue is output voltage waveform. As you can see that both are overlapping and both are same to same, because the input voltage directly comes to the output. So if you want to remove these settings out of the picture, you can click on this settings over here at the top and you will be able to see that. Now let us modify the circuit. What to modify? Let's add a diode in the circuit such that we will be able to rectify this AC waveform. Now presently we do have an AC waveform which fluctuates from a 0 to a maximum value and comes back to 0 and goes to the negative and again comes back to 0. That is one cycle, and the cycle continues, the cycle repeats by itself. Now we will add a diode which will allow the current to flow only in one direction, such that we will be able to use that diode as a rectification component. How do we use the diode? Let us now come out of this simulation mode by pressing this stop button. We have come out of the simulation mode, and let me click on this schematic so that I can take out the waveform and I'll arrange the circuit in the right place. Now I'm going to modify this circuit by adding a diode. As we all know that diode allows the current to flow only in one direction. That is its feature, and now we are going to use a diode such that we try to rectify the supply voltage waveform, which is a sine wave. Sine wave will be rectified. Let us see what will happen. Right, where do I get the diode? Coming over here, you can see that there is a diode symbol over here. Click on the diode symbol. You can see over here there are different types of diode, Zener diode, LEDs, general purpose diode. So let us click on this diode, and now let me keep it over here. Right, so where do I put this diode? So before putting the diode, I'll be disconnecting this wire. So you can see that I've clicked the wire over there, and I'll be clicking on this delete button so that I have removed the wire over there. Let me remove these probes also for now, so that we will connect it later on. So I'll move my diode to that particular place, and again I will rewire it. So let us rewire it. So one part of the wiring is done, and there you are. So the rewiring is done. Let us now again connect the probes back to the supply and also to the output load resistor. Yes, there you are. So now the diode is connected to the source, to the load. Let us see what will happen. As we all know that diode is going to allow current to flow only in one direction. Let us see what happens. Let me click on this play button over here so that the circuit runs. There you are. The circuit is running now, and now I can click on this pause button so that it will stop at a particular place. And let me click on this split so that I can see the schematic diagram along with the waveform at the right. You can see that it is very clear. The green waveform, which is the input supply voltage, green as you can see from the color here from the voltage probe. The green is the input voltage supply sine wave, and the blue one is the output. As you can see over here, the blue one is a half wave. It's only half wave. Half of the wave only comes at the output, and the remaining half is just neglected or removed from the output. You can see that the blue goes 0 at that particular point, and again it continues with the input waveform, that is a green waveform, till it comes back to 0, and again it remains to 0. That means that all the negative voltage, that is the voltages which is coming below this 0 to -10 and going back to 0, are getting removed, and this is done by the diode. So that is a waveform, that is a half wave rectifier. This is called half wave rectifier. Let us now save this circuit as a half wave rectifier. For saving this circuit, as I've told before, first you have to click on this open information pane, and you can put a name over here. Let me put it half wave rectifier. If you want, you can put your descriptions also over here. Let me put just the name, and let me save that. So for saving, you have got to come over here, this 9 dots you can see over here. Click on that, and by clicking on that you will be able to save this document. Yeah, now you have saved that. This schematic is saved online, so that whenever you want to access this again, you will be able to click on that and open this particular waveform online. Right, so there you are. So we have developed our second circuit with diode as a rectifier. So we have seen that diode is useful for us to rectify the input sine wave, and we have rectified it half wave. But when we ask whether is it a DC, no, we cannot tell that it is a pure DC because it is still fluctuating. You can see that it goes over from 0 to maximum 10 voltage and comes back to 0. Of course, you can tell that the voltage is only positive here, but it doesn't go to negative. Still, we do have a lot of jobs here. We can see that half of the wave is not coming into picture and it is wasted at that particular point. So how can we modify this circuit such that we can use this negative half cycle which comes at the input, so that we can transfer it to output so that it will be effectively utilized. So that would be our next circuit. Let us now modify this circuit by making this circuit a full bridge rectifier, wherein which I will be using 4 diodes at the place of 1 diode, so that I utilize this negative half cycle effectively at the output. So for that, let me first stop this simulation over here. Now I have stopped the simulation. Now instead of connecting the 4 diodes, we will open up a saved file which is already available over here. I have already saved that full bridge rectifier. Now I will open up the saved file and then we will work on that. So for getting the saved file, I have to click on this 9 dots over here at the top left corner. Click go to and my circuits, save. Yes, you have unsaved changes, save, and now it will take you to the saved circuits which you have already worked on. Okay, here we will click on this full bridge rectifier. Full bridge rectifier is over here. Let me click on that circuit, open circuit. There you are. So that is the full bridge rectifier. You can see that there are 4 diodes, D1, D2, D3 and D4. 4 diodes are used for this full bridge rectifier. I will be explaining in detail about how the current flows from the source to the load resistor. As we already know that this is an AC supply voltage, and this AC supply voltage has got both positive half cycle and a negative half cycle. Let us have a look on the positive and negative half cycle first. I will run this button and let me click on this split, so you can see that the schematic and the waveforms are in place. Let me pause this. Right, so as I have told before, the green voltage probe is the supply voltage and the blue voltage probe gives output voltage. And you can see on the right hand side the waveform starts from 0, goes to the positive to its peak and comes back to the 0 and again goes to the negative half of it, then goes to its negative peak and comes back to 0. That is the complete one cycle, and after that it repeats. This is what happens, and this is how the source voltage behaves. You can see over here in the source voltage there is positive and negative given. Normally for AC supply voltage it is not positive and negative, which we normally call it as a phase and a neutral. P and N is what we normally represent AC voltage. Positive and negative we normally use it for DC voltages. Why it is so is because in AC supply voltage there is no permanent positive and negative, or as you already know, at one stage if you take an instant of this AC supply voltage, it can be either positive or it can be negative. So similarly, when I play this, you will be able to see that here. You can see that it is continuously moving. It can be positive or it can be sometimes negative. So that is how it is. For an AC supply voltage, there is no permanent positive and negative. For that instant, we will normally represent an AC supply voltage as phase and neutral. The upper part can be termed as a phase and the lower part can be termed as a neutral. And now let us discuss how the current flows in the positive half cycle and also in the negative half cycle. Let me just represent it here. Let us take this phase first. So from here in the positive half cycle, I will show you how the conventional current flows. As normally represented, we can represent it as a conventional current or electron current. Conventional current is the method which we normally use. Electron current is the flow of electrons. It is just the reverse of conventional current. Let us keep it to conventional current and start explaining the flow of conventional current in the circuit. So from here, from the phase, it starts move through this line in the positive half cycle, comes to this junction. From here, as you can understand that on the right hand side it moves. Why it moves to the right hand side? As this diode will be forward biased in the positive half cycle, and it goes through D1, comes to this junction 2, and then it moves to right. So it cannot go straight because again the diode over there is reverse biased, so it has got to move in this line, come through the PR2, it has got to go through the load resistor R1 and complete its cycle, come to the junction 1, and from here as you can see that it won't go through D2 even though it is forward biased. Why? Because it will reach back to the supply to the same point from where it has started, which it cannot normally go, and basically this voltage here would be higher than the voltage which is over here, so the current will not flow through the D2 because again it cannot go to reach the same point. So it has got to come through D4, comes through the D4 at this junction, it completes the cycle and reaches the neutral of the supply voltage. This is the positive half cycle. So also one more thing, you can see that you might be a little confused about the diodes, how the diodes are placed here. To make it very simple, let us put it this way. We have got 4 diodes, D1, D2, D3 and D4. Let us keep right hand side diode looking down, and all other with respect to that, when you take the diodes which is nearer to it, let us reverse that. So you can see that D1 and D2 are reversed from D2, and D4 when you see that is also reversed. So with respect to each diode, when we see the 2 adjacent diodes, that is with respect to D4, if it is D2 and D3 are the 2 neighboring diodes, and those 2 you can see that it is completely reversed. So it is very easy, comparatively easy to construct this diode and also remember first diode how it will be acting, and with respect to that you can adjust all other diodes, then your circuit will be working fine. So coming to the negative half cycle, this neutral, this would be the starting point, the down part would be the starting point, and the current flows through this line, comes through and reaches this junction over here, and from here it moves through D3. So this is the path which it takes, as D4 is already reverse bias. Through the D3 it goes in, comes through the same line R1, the load resistor, comes through and comes to this junction 1. From here it will go through D2. Why D2? Because this neutral is the line where it has already started, so it cannot go back to neutral, it has got to go to the phase. So from here it goes through D2 and completes its cycle, reaching the P part of the supply voltage. So this is how the whole cycle is all about. This is how the current flows. In this, one important point to be noted here is the load resistor. Through the load resistor the current always flows in the same direction, that is from this junction 2 to the junction 1. So it is always in the same direction, both in the positive half cycle and also in the negative half cycle. So this is what you can see on the right hand side. So the green one, as you already know, that the green one is the supply voltage, and the blue one, which is represented by the voltage probes, is the output voltage. You can see that the output voltage is rectified, it is a DC voltage. How it is a DC voltage? Because there is no negative part of the output. All the negative parts are removed and now it is only positive half cycle. So that is why we can tell that it is a DC. But is it a pure DC? No, it's not a pure DC. Why? How can we tell that it is not a pure DC? It's very clear at the output. For a pure DC, if it is 4 volt pure DC, it goes straight line. So that is how a pure DC is. This is a fluctuating from 0 to a maximum of a 4.2 and coming back to 0, and this is a fluctuating, or we can tell in other words that there are ripples, and a huge amount of ripples are available, and it is not a pure DC. So this has got to be filtered. This AC component which is available in this DC is removed, right? So that is full bridge rectifier. As I have told you, the output is a DC, but it is still fluctuating. It has got ripples, so you can see that 1, 2, 3, 4, so it is having a ripple. So we have got to make it a pure DC. So what to do for making it a pure DC? For making it a pure DC, we have got to introduce filter capacitors. So filter capacitors has got to be introduced in the circuit, and what does that do? Filter capacitors filters out this AC component. This is an AC component, the behavior of AC supply. As you can see that even though it can be called DC, but it has got a behavior of AC supply, and this AC component need to be filtered out, and for that we use capacitors. So where do I get capacitors? Before getting capacitors, let me stop this run mode. So that is stopped. Let me remove this waveform out of the picture. So let me click on schematics. place. There you are. So let us now connect capacitor into this circuit. For getting capacitors, go to this passive, click on this passive over here, click on this capacitor. So we will place it at the particular place. Let me double click on this capacitor, click on this symbol. In this symbol we will be selecting this electrolytic capacitors. You can see that this is capacitor with polarity. We will be selecting this, right? So I have modified the capacitor to an polarized capacitor. As you can see that one side it is a positive terminal. So we normally use a polarized capacitors for filtering. So we will rotate this now. Click on the rotate button, and now you can see that it is already rotated. Let me keep it at the right place, right? So let me wire it now. So for wiring, you have got to take your cursor near to that one of the edge, click, and then connect the wire. So you can see the same thing. I've got to do it at the other end. There you are. So basically by default it is 1 microfarad which will be selected. You can also change the value of capacitor. For now let us keep it 1 microfarad, and let us try running this circuit, and let us watch what is happening in the circuit at the output waveform. For that we will click on this run button, run or play button, which we can call. Now it's running. Let us put it in a split mode so that we can see the schematic and also the waveform at the same time. Let me stop it by clicking on this pause button. There it is. You can see that the waveform has been very much filtered out. You can see the ripple has come down. Previously it was starting from 0 going to a maximum and coming back to 0. Here you can see that this is much higher, and you can see it's almost a DC with a very small ripples. So how does this happen? What is the concept behind that? For that, before explaining that, let us first understand what a capacitor is, how a capacitor behaves when you provide a DC voltage to it. Let us assume this is a capacitor equivalent to a glass. So now when I provide a positive half cycle of current, let me consider it equivalent to pouring water into this glass. In the positive half cycle, when the voltage goes from the lower value to the upper value, the water will be poured into this glass which is already taken, and after when it reaches the peak, then the input reaches the peak and it is coming down back to 0. So in that thing is that the voltage here, the voltage supplied to the capacitor is coming down, but the capacitor has got a property to retain the voltage and it will get discharged very slowly. How is that this glass will get charged and how it is discharged? Let us see that. In the positive half cycle, wherein which it goes from 0 to peak, the glass gets filled up, and when it comes back down towards 0, there is a tendency of the voltage dropping down at the output, but the capacitor holds on that, as the capacitor will provide that extra charge required, extra voltage required to the load resistor, and this is a discharge wherein which the water, when you consider this capacitor as a glass of water, the water is getting removed from the glass. So this happens very slowly. Why? Because there is a resistor in place, and higher the resistor, the capacitor gets discharged very slowly. In the charging side, there is no resistor. It comes from left and comes to the glass, wherein which the glass is getting filled. So filling of this happens very fast, while discharging, the removal of water, happens very slowly. Why? Because here you can see that there is a resistor, and when you compare it to current, more the amount of resistor, the flow of a current will be lesser. When you take this glass of water as analogy to circuit of a current, so at the input there is no resistor, so filling of the capacitor, or when you take it with respect to glass, filling of the glass with water is much faster, while with respect to removal of water or removal of current from the capacitor. So that is why when you charge, this capacitor gets charged to a higher voltage, but when you try to discharge, when the input voltage tries to come out, the capacitor is much slower in responding to that input voltage. So that is what you can see, that when the input voltage goes to 0 and again goes to the negative, capacitor still maintains that voltage, but of course it discharges. That is why it comes down, but it is very slow compared to the input. And why it is slow? It is because of the resistor in place. And at this place, because it has been already rectified, this voltage after rectification from 0, it will again again go to the positive, and when it goes to the positive, at this particular point the capacitor again gets its voltage and again charge. So the upper part in this blue curve is the charge of the capacitor, or when you take it with respect to glass, it is filling of water, and the downward part is discharge of capacitor or removal of water from the glass. So this is what it is being continuing. As you know that at the output voltage after rectification, the output voltage will go from 0 to positive, comes back to 0, and again goes from 0 to positive and comes back to 0, which will gets repeated. So this is what capacitor does. Now how to filter it further, how to remove the AC content in the output voltage further. So it is comparatively very easy. Just increase the value of the capacitor. You will be able to further filter out the AC component from the DC output voltage. Let us see that how it is effective. Let us now change this value of this capacitor from 1 microfarad to 10 microfarad. Let us double click this capacitor. So from here you can see that you can change it to 10 microfarad. Yes, there you are. So I have changed it from 1 microfarad to 10 microfarad. You just closely look through the waveform which you have already got. Let me run, and you will be able to see the drastic change which has happened. There you are. You can see that the DC voltage at the output has straightened much better. It has become more closer to a pure DC. So further, if you increase the capacitor value from 10 microfarad to 20 microfarad, you will be able to see that it further filters out and the ripples gets removed. So that is the effect of the capacitor. Similarly, let us change this value of a capacitor from 10 microfarad to 0.5 microfarad. Let us change that to 0.5 microfarad. Now it has been changed to 0.5 microfarad. Let us see what happens when we run it. You can see that the ripples, it is a big ripple comparatively, and compared to the 1 microfarad, the ripple has gone up, and that is how the effect of a capacitor is. When the capacitor value is reduced, the ripples increases, and when the capacitor value is increased, you have already seen that the ripples gets reduced, and that is the effect of filter capacitors in full bridge rectifier or even any rectifier. So if you want to remove AC component in a DC output after rectification, you have got to use these filter capacitors, and this filter capacitors, as I've told, it will be able to maintain the voltage within itself, the voltage which has come from the input. This is the input to the capacitor, and this is the output. So this is charging of the capacitor, and this is discharging. From charging happens from 2 to comes down and goes in. So that's how charging happens, and during discharge it is the capacitor is discharging, and capacitor gives out the voltage. The objective of the capacitor is to maintain the voltage. So when the input voltage tries to come down below the voltage which the capacitor has got, the capacitor itself acts as a source of voltage and it discharges to the load resistor. That is the objective of keeping this capacitor at this particular place. That is, whenever the input tries to fluctuate from a fixed voltage, this capacitor tries to maintain that. That is how you are able to see that the output it tries to maintain, but here you can see that this is the discharge of the capacitor. It tries to maintain, but of course it discharges, some voltage is discharged, and that's how it is slower compared to the input voltage. It is slower, and from here again it actually continues with the rectified voltage along with the rectified voltage and comes back, and while discharge it is slower. So the charge happens at the same speed while discharge happens at a slower speed. So as I've indicated before, capacitor can be referred to as a glassware in which you fill the glass with water, so that can be called as a charging, while the removal of water from the glass can be called as discharging. So it is as simple as that. Right, so let us take this value for this capacitor back to 10 microfarad. You will be able to see that it is coming back to almost a pure DC. Let me run it again. Here you can see that it has come back. It has almost become a pure DC. When you further change from a 10 microfarad to 20 microfarad, you will be able to see that it further removes that ripples and you get a pure DC at the output. That's the end of AC waveform, its rectification and filtering. Hope all of you have enjoyed watching this video. Let's meet again in my next tutorial. All the best for your online learning sessions. Thank you.